and I hope you will enjoy this talk for today because definitely it's going to be fun. If it's for profit, we'll have to find out. Let me introduce myself for a bit. I am the CTO for indeed wholesale banking advanced analytics slash artificial intelligence at ING Bank. ING Bank is a pan-European bank with some additional departments in other countries. I'm also the vice president for Apache Airflow, and I've contributed to various Apache projects in the past and continue to do so. I run teams in Amsterdam, London, Warsaw, and Bucharest. So if you're want to join us there, reach out to me as well later on. But today I'm going to be talking about data lineage and airflow, and actually what kind of problem this is hopefully solving. I don't know if you know, but there's a lot of wasted time with technical and business users in doing things with data. So there's a lot of time being spent on data discovery. Basically, where is my data? What can I do with it? And exploration. What does this data actually mean? And then we develop models and productionalize these models, which then take 40% of our time. And visualization and communication, basically putting it in an app or putting it in a report, is taking just that 10%, right? Which is a bit strange if you think about it, because where's the value at? That's in visualization and communication. Well, not so much in discovery and exploration. Next to that, understanding data is actually quite hard. What is happening in your data, for example, in this outlier, what's going on there? So if you're dealing with data in any way, you're going to be interested in understanding and monitoring this data, and you want to have tools that help you out with that. There are also many side effects of not having the right information available, because you'll start asking yourself, does this data actually exist? Is there prior work? Or what's the source of truth? Who owns the data that you're dealing with? Who uses it? But there are also technical challenges with it, like, hey, if people do not understand what the behavior of the data is, they will just select star from the table to actually find out what this data is about. But not knowing where the data is coming from also puts you in compliancy challenge, especially with GDPR and CCPA in California being more and more prevalent there. So there's no way to know and understand where trusted data is actually. So the holy grail to this is metadata. And metadata is a set of data that describes and gives information about other data. And the question becomes is, hey, what kind of information is that? And what is that other data then? If you think what kind of information that is like, and this is what Mark Grove from Lyft calls the ABC of metadata, is we need to put it in an application context. Metadata is needed by humans or applications to operate. So where is the data and what are the semantics of this data? And then it says, hey, how is this data created and how is it being used over time? So who is using the data? Who created the data? And then finally, it's also, hey, there's change in data over time, and how is it evolving over time, and what is the evolution of the code that generates this data? Those things you need to be answering if you're going to mature in your data offering inside your company. But what data are we then talking about? Well, basically, we're talking about all the data within the company that you're shifting around. So that can be your data stores with Amazon S3 or in Hive or in Postgres. It can also be people, because who's using the data is important to answer. But also in dashboards and reports like Looker, Tableau, and Superset, which Max is nowadays creating. But also notebooks and events and schemas and streams with Kafka and Amazon Kinesis. What is the goal of doing all this? So it's actually to reduce the time to find trusted data and improve productivity. And this is search based or lineage based or network based or programmatic. So search based means, hey, where is this table for question X and what does it contain? If you're creating a new analysis, you probably want to know, so if somebody else already created that analysis and can you already reuse it? Or if it's lineage based, is, hey, I am changing a data model. Who are the current owner and what are the most common users? Because if you change it, you probably need to notify them if you're doing anything with it. Or this table's delivery was delayed, so I want to notify everybody downstream that they need to adjust their schedules or something needs to happen. But it's also network based. Imagine if you're a new data scientist entering in a team, then what normally would happen is, hey, I'll go to the most experienced person in that team and we'll start asking him, hey, can I basically sit down next to you and understand what tables you're using, what data sources you're doing. But if you make that easier, especially the times of COVID, where it's actually quite hard to do so, then you want to be able to follow a power user in your team. I also want to be able to bookmark tables of interest and get a feed of data delays, schema changes, and incidents. So I can monitor my own data sources that I'm going to be using and not rely on other persons, basically, or other teams to notify you. And finally, there's also the programmatic one. Because you want to access metadata programmatically, that makes it then easier to, for example, do PII removal. If you have data sets with that PII information in there, you want to make it possible to automatically remove those. And finally, you want to maybe put in the way of a pull and push metadata programmatically so that you generate that metadata. And at some points, I will actually touch in this conversation that we're having in this presentation how Airflow can help in a couple of those directions. But first, I'd like to introduce you to Amundsen. Amundsen was created by Lyft. Although its name is come from the first person to discover the South Pole, and he's called. It was a Norwegian explorer called Roald Amundsen. But Amundsen, as we were talking about it, was created by Lyft and was open sourced in 2019. And my company are backers of that, and you can find Amundsen on a GitHub. The link is on the page. What Amundsen does, it actually enables data discovery. And data discovery is basically Google for data. So if you type in, hey, I want to search for a table and I'll find it in the data sets, you get that back and you'll see it basically also on a relevancy level. So if I type in, it's page rank based and it's popularity based, popularity score based. So the more users of a particular table are there, the higher up it will get into the result list. This allows you to find relevant data sets and see the details of these data sets. So as any one of you would know, is if you have a Hive table, then you probably want to know, hey, what kind of data is in there, from when, what are the date ranges for it, who are the frequent users, and obviously what kind of columns are in there. Then it allows you to dive in to what the descriptions in the profile of the column actually is. So the typical things like distinct values, the number of nulls, the verified artifacts, and what are the min and the max numbers are being displayed, while we're also working on more population monitoring over time. We'll get to dashboards in detail as well. So dashboards, as I talked about earlier, are also about the things like that you put in the Looker or in Tableau or Superset, where you also would want to find those again, because you don't want to recreate reports that you've already done. And all those reports are going to be dependent on the data sources that you've created. So you already see a picture of a linked linked items from the initial data source to the report that you're putting out, either to a user, a manager, or a regulator in our case, you probably want to find out how those reports actually came to be, not just by saying, hey, this is a very popular table, but you also want to know how this report actually was built up and with what kind of data sources. So how to power Amundsen then? Because after all, this is an Airflow talk, and we're not talking about Amundsen in itself. So remember the Holy Grail. And the Holy Grail was about metadata. And I hear you think, right? I mean, but metadata is boring. And if you see how it's being handled in many occasions, I would even argue XML is the pinnacle of metadata. Nobody likes to write XML. Java switched to annotations, but nobody really likes those annotations either. And people will say metadata is boring because it basically hardly adds something to the experience of the developer. It's often annoying. It's just admin stuff, boilerplate often. My users are not adding metadata, which is always a challenge, right? I mean, we can't invent it. So the column descriptions, somebody needs to get them and needs to put them in. And if you think about it in an Airflow context, well, it was explained earlier also already during the keynotes, that Airflow is task-based. So if you're doing something with data on top of the task-based parts, that is actually a bit hard to do, or it might conflict with the philosophy behind Airflow. But if you think about it, if you want to solve the earlier problems or the earlier challenges and make data discoverable, or make sure that your reports have the right steps that you can tell your regulator or anyone else, basically, where's the data coming from, what transitions did it go through, then there are steps to be taken, and I think we can make it easier. So make metadata great again. I think it's a slogan that will stick. I've seen it happening with other slogans like this, but I think keeping code easy and not to add unnecessary metadata constructs is an important principle for this. And we also need to ensure extensibility, because everybody or every company has its own domain language, and we can't force people to use a certain language. So we need to make it extensible. It needs to integrate with Airflow's task-based workflow orchestration and not be something that changes the whole paradigm. It needs to be an addition to the paradigm, which allows you to combine both, basically. And of course, we need to make sure to be backward compatible. So there are kind of couple of simple constructs that that are part of the maybe the metadata thinking or the metadata concepts. And basically, it all starts with a file, right? I mean, everything we do within Airflow, it actually has a representation somewhere on a file system, or you can think of it as a set of bits and bytes together that's just storage. So that's the most simple concept that you can think of, and it has a URL associated with it as well. So because then we know its location. Then many of the things that we do still need to deal with tables, because even if you're working with unstructured data, often what you do is actually change it from a unstructured format to a structured format, which is basically often a table. And this table will definitely contain a database, because it's located somewhere in a database. A cluster, because it's part of a place there, and it has a schema associated with it. And a table can contain columns, which makes sense, I guess, because that describes what's in the table. So obviously, then we have columns that are they contain a set of data values, all of a single type in such a table, and a column has a name. Then finally, which is kind of a overarching thing, is that you actually can tag those items as a name of a category. So let's say, hey, this is PII information. I can tag a column with that and saying, hey, this is PII information. It gives extra meaning to that column, but it's also transcendent to, for example, files. So if you say, hey, I have a file which is tagged with PII information. If a table is based on this file, most likely it has this PII information in it as well, except when it's explicitly removed. And the same thing goes for the column. So here you think already that you see a couple of concepts being added. But these are extensible concepts, and these are these are the starting concepts that you can start working with in Airflow. But if you want to create a new metadata type, that is actually quite easy, because you just need to derive from one of the earlier ones. It's not even required because you can even leave that out, but it needs to be serializable by C attributes. And that's getting quite popular. It's easy serializable with the attributes. You don't have to do a lot of boilerplate. You just define the parameters that you think make up your domain specific things that you are require. So here you see an example of that. You can create a notebook, for example, a Jupyter notebook, and you say, hey, what kind of parameters did I actually add to this notebook? And that's a dictionary. That's the only thing you need to do. It's not going to be much more complex than that. Obviously, you can make it complexer if you want to, but this is quite a simple thing to do. So then we can already talk about it. I'm actually going a little bit fast, I guess. Let us see how that then actually works in practice in the upcoming Airflow 2.x. And I know I've been talking about it for I think already 2 years, and it has been going through pivoting moments on how to deal with this properly. And I think that the most difficult thing was actually to integrate it with the task-based system of Airflow, but also pulling in the concepts from, for example, Apache Atlas and nowadays Amundsen. And I think with the drive of Amundsen, it made it quite a bit easier. But let's dive in a little bit. If we could actually then make it a little bit easier how to deal with that metadata. So here you see like a kind of outline of a DAG that starts off with a source that we want to translate some currencies that I get from Coinbase, and I want to do investment predictions towards the future. So it's a conceptual thing, but I want to tell the system that, hey, I'm actually picking up a file from somewhere, and it is defined by this API call, and I will actually put it somewhere else. And it helps with the execution date and the version attached to that, so that I can use it for reproducibility. And with a simple HTTP operator, I will get the currency from Coinbase, and just by telling this operator where the source and the destination is, I will put this. I'll extract the data from Coinbase and put it in an S3 bucket. Then what I would like to do next is to prepare a machine learning model. I've already trained it, so it's just doing predictions. And I will tell where the predictions need to end up, and how those predictions are being created through a Spark submit operator. So as you can see, what is a bit different from your normal DAGs here is that I will define a file instead of just a location which I'll set to and I'll call it an S3 operator, and I'll pull it in and then tell it to go and I'll pick it up from the simple HTTP operator, pull it in through S3 operator, and then bring it over to the Spark submit operator. I can actually do that more or less in one go now by just telling to the file definition, this is S3A, so this is for S3, and for HTTPS, obviously this is going out to the internet. Finally, if you see, there's a bit of a shorthand notation now available where you say, hey, and maybe people that have a Unix background recognize some of the pipes and the other notations that you say, hey, I actually put in source I put it into get currency, which is the simple HTTP operator, which then sets the source for the HTTP operator and puts it out to the destination place without actually doing a lot of, I would say, meta programming if you want. But it makes it actually quite easier. This then you pipe to create predictions, where create predictions then uses the output of what get currency actually created and put that into the predictions file. Now this is already a little bit, I would say, this already would give you lineage information if you want, because now I can tell from source till predictions what the steps were within the system and to actually get to predictions. But we can go one step further. So what if we do not care about the intermediate file? So if I go back, we had the destination file in between. If I can use my mouse a little bit, you will see it here. This is a destination file. That's an in-between file, which I might not really care about. So can we not make that a little bit simpler even? So again, we have the simple HTTP operator. We don't have to look at that. But we actually removed the destination file, and we just pipe get currency to create predictions. And this will tell Airflow, hey, I have an undefined destination. Therefore, I need to create a temporary file at a configurable location, and we're thinking about doing that on only an object storage, for example, because Airflow itself, if you do it in this on the scratch disk with a temporary file, people maybe start abusing Airflow to be to do really something with data, and that you put it into the local worker. I don't think that's what we'd like to, but that will be configurable to the administrator. And from that, instead of having the destination file which you then define, it will just directly pipe through to create predictions, and you'll get the output in predictions. So you can actually skip a step, which you would normally do in your normal DAG creations when you would do it like this. But we can take it even one step further. So here we want to load the data into a Druid table. So again, we start off with the source from Coinbase or CoinDesk. We get the currencies again, but we know now that we want to have a prediction table called invest predictions, and this is going to be located within Druid. So we still have the create prediction side for the Spark submit operator, and we have another step called load in Druid, which is just picking up the output from Spark and then puts it into its own data source over there. And putting it together is that you see we have a source, which is that source file, which is then being told to get currency, piped to create predictions, piped again to index in Druid, and finally it gets to the output of prediction table. So hence we're again not having to define any of the intermediate files that are being created, but create predictions and index in Druid will figure out themselves how to exchange the information they have. They want to exchange with each other. And note that in this case we actually wrote quite a lot less code. While we did add metadata with this, while maybe that actually you didn't even directly see that, but because the tasks are now aware of where their sources are from now, they can actually make this available inside Airflow. So there will be and it's already there actually, an exchange format through XCOM at the moment, but we might pull that out to show where a lineage is coming from. But it can also send it to external systems like Apache Atlas or Munson, for example. But it can also enrich it from there. So if you imagine here is that you can just use the file and then enrich it with information that's inside the lineage system And for example, this could contain, hey, this is tagging information for PII information, and then remove based on those additional tags where PII information is inside your tables. Well, you wouldn't even know what kind of table it is. So this would allow you to generalize some of the DAGs that you're creating, where for now say, hey, remove PII information from table XYZ and do it like this. Is that you could now say, hey, I have a generic DAG that says I remove PII information from any random table that you give me, as long as I get the right metadata information from the external systems. So that would make your DAGs actually more scalable, while you're still ending up with the same results. So for the example I just gave you earlier is, hey, we had, and I'm switching back, we had the get currency with the simple HTTP operator, we had the prediction table, and we had the load in Druid. So here you had, hey, in Airflow, you see the get currency, create predictions, and load into Druid. And I hope we'll visualize it a little bit nicer for you, that you also see the lineage information, excuse me, the lineage information that is going to be shared between those tasks, and when it's not there sometimes. But if you'd like to see what what it looks like in Apache Atlas, for example, is the lower picture, where you see we're picking up from something like in CoinDesk. We're building currency predictions, which is a process. It gets to a file in a bucket. We do a currency predictions, and it gets to an output again. We'll do a currency prediction again, and we have to get to the output to Druid. So here you see the in between steps that we actually did not define. So the in between files that were not defined in the DAG but are created, and you get to the final stages. So excuse me. So what will you need to know? Airflow will connect to Apache Atlas out of the box for external enrichment. So think about it: ownership, column information, and external registration. A Munson can be added when it exposes the right APIs. And eventually, audits can also be added. Think about Google's data catalog, for example, or I think there's something called Waterline that can also be used if needed, or Cloudera's offering, for example. Airflow's lineage model will closely follow Amunds's data model. So the tags, dashboard, the columns, and tables. If any one of you is familiar with the Amunds's code base, you will actually see that those are exactly the same as they were defined over there, and hopefully you can actually even base them on the same code eventually. And APIs will be available for extracting lineage information from Airflow itself. So if you do not have like an integrated push-based model that Airflow will support, you can actually do how Amundsen actually does it at the moment, is do it pool-based. You run most likely an Airflow job, which then pulls out from the APIs of Airflow itself and then puts it in somewhere else. Well, I ran through my slides a little bit quicker than I expected, but thank you very much for attending, and I am taking questions now if you're interested.
Yes. Thanks, Bolke. I was going to start with a quick question from me, if that's okay. Where
Sure.
The state of the development of the new things that you've described there, where are we in that? Are we at the starting line, or is this stuff in progress already?
I think we're about 70 to 80% at the moment. So actually quite a lot of has been in. We've had an earlier iteration of this, as some people actually been using it. I was surprised to find out people were using it. Otherwise, we would haven't replaced it actually as we did right now. So apologies for that. But I think we're about 75 to 80% there. I think the main things are around integration with the external systems, how to do it properly, to make it resilient against failures too, and how to build in that resiliency in the proper way. Do you fail when you do not get that external enrichment, or how are you dealing with data that might not be there while you're expecting it to be there.
Yep. Okay, so we're taking questions now on Crowdcast and in the Slack channel. The highest voted question right now is, it says, it's from this guy named Yarek. Are you working from a garage, Bolke? Seems like common in early days for most companies. So,
well, no, actually, I'm at my neighbor's place. He was kind enough to offer me a somewhat better place than I had in my own shed. There was better lighting here, and I'm grateful that he did. So, no, not my own garage, but we sometimes share this place. Yes, indeed.
Great. Another question. It says, have you tried to use lineage with the functional DAG implementation that was recently merged into master?
Honestly, no, not yet.
Yep.
It will actually, but it will, the functional DAGs do make sense in this space. So, and in lineage, you don't want side effects, which functional DAGs and functional programming are, important for. So in that way, I think that would be a match made in heaven.
Great. All right. Good. Next question. Next highest voted question is, how can we use Adminson and Atlas with containerized workflows? Any thoughts on that?
Well, I'm surprised by the question because I'm not entirely sure what people think is standing in the way of it. So both Amundsen and Apache Atlas can be containerized themselves. They run with API calls, so as long as your operators can send out API calls to those systems, then it should not really be an issue. You might think about security, obviously, with your tokens, but particularly in Kubernetes with the sidecars and with the vaults, that should be something that is solvable. Maybe there's a follow-up question that gives a little bit more background why somebody thinks that will be a challenge.
Yep, sure. Feel free to post a follow-up if you have a follow-up. Next question is the integration with GCP data catalog also being considered?
Well, that is obviously up to the community. So my company is based on Apache Atlas. We will do exchanges with something called Egeria, which is in the works, which is a very enterprisey thing. And data catalog will eventually, as far as I know, integrate with Egeria too. So that might help. So Egeria might be because it has multiple connectors too. Is more a federated, more of a federated lineage sharing. But I assume that data catalog has somewhat easy APIs, wouldn't be too far away, and so why it wouldn't be is we're not it's not holding it back. It's just that we're not using it ourselves. So how do you test it? Is then the question. But if the community wants to contribute it, obviously, then it would make sense to integrate it.
Yeah, and just real quick, Egeria, could you tell us a little bit more about that tool?
Well, Egeria is a federated metadata exchange, so it helps with, for example, between Apache Atlas and IBM's IGC to federate the different metadata accesses. Because in a company like mine, we are definitely let's say a confederation or federation of different entities within the company. So they are not all going to be Apache Atlas based, for example. Some others will use more IBM IGC in this case, and there might be other examples around.
Cool. Okay, how does lineage creation work if you do data processing not inside of Airflow, but in a microservice that you schedule via Airflow? Is data lineage creation in this case still possible?
Well, yes, that is possible. The challenge always is how much detail do you require? So a lineage is about inputs and outputs, but you sometimes also want to know, what the transformation was, what something went through. So if you schedule something with Airflow, I assume you will know where the data started basically and where it will end up, and it can be a table or not. So the most simplest version of that is that I know I have a file on the end, as a source. and I know I will get a file as a destination, and I know that I did a operation on that, and but I only know that this operation happened. If you run a Spark job, for example, this could be the case. But if you provide output inside Spark, you might be able to parse the output of Spark there. And the fortunate thing with Apache Atlas, for example, is that it does integrate with some of those services. Hive is an example for here, and there are some others around it as well. Although they are a bit more Hadoopy, so I don't think Google, for example, integrates well with those. So you need to help Airflow then a little bit more by providing a little bit more metadata. That's unavoidable until depending on your needs. So yes, it depends on the granularity that you need.
Yeah. So to summarize, that sounds like some tools have the integrations built into them. You could send data directly, or you could return some data back to Airflow that it could use to update the metadata,
yes.
or I should say lineage data. Yeah.
Exactly. The whole idea actually behind doing it in Airflow is actually to plug the gaps basically, because if all the tools would do it perfectly, you wouldn't need Airflow to do it, because then it would automatically happen. That doesn't happen, so hence we're doing it in Airflow, because if Airflow is the orchestrator, it will know it from the end from the beginning till the end, and it can plug the gaps.
Yep, good. Next question. Is there any other way to get data lineage from Airflow without using Adminson and Atlas?
So yes, there will be. As I explained at the end, there will be APIs available that will allow you to extract the information through APIs. So that will be a REST API call, and then you can pull it out. The other one is creating basically the plugin for instead of Amundsen or Apache Atlas. The challenge you'll face is basically the mapping between the objects that Airflow knows and what your data lineage system then knows. So what's a file? What fields does it have? When you're in Airflow, it has just a URL. Maybe you require a little bit more. And what's the mapping there? That's what you need to create. That's what I'm doing for Apache Atlas, for example. And that will take you a little bit of effort. And I try to make it as easy as possible for others to do it as well. But this is where your effort's going to be. Otherwise, you'll need to do it through API calls, but you'll still need to do that mapping then for obvious reasons.
Great. Questions are rolling. Here's another one. Is there a feature being worked on or would be worked upon for tracking task status, kind of from a monitoring standpoint to check the current status of the flow of data in a pipeline, or could we use lineage to drive these insights at a point in time?
I honestly think that's a little bit out of the scope of this of the talk in itself. I think it's a nice feature to have, and I would definitely therefore say yes, but I don't know who's picking it up. So let's put it high up on the feature list, but it's not driven from the lineage part. That's not where it is being done.
Yeah, it happens to be something that I want to talk about on my Thursday talk, by the way. So yeah.
Here we go. Problem solved. Yeah, I'm here. You're going to be doing that.
Well, this is a future thing, but yeah, I agree. It's a great thing that would be useful in Airflow. All right.
I think and progress taskbar, progress bars. These are really nice things, but they're hard to generalize due to the maybe you can do predictions on tasks if we know them from the past, for example. But so they're just as hard maybe as to get lineage information from the different systems, because they're pretty domain specific. Again, like how do you get them from Hive? How do you get them from Spark? How do you get them from Presto? Do you know when they're complete? Do they give out that information?
I think it'd be great if Airflow had an API to receive the data. And once again, if the tasks plug into it, great. Otherwise, you could do things like you said, just estimation based on previous runs and stuff. Yeah. Cool. Right now, we've got one final question. If any more pop up, we'll keep going. But right now, if Airflow is pulling code directly from Amundsen in its current form, do you have to worry about changes to the models in either repo causing issues with the integration?
The obvious answer is always yes, of course, because this is an integration test between the two of them, right? And if the interface changes between them and they're not well tested for whatever reason, then you'll face these things. Honestly, at the moment, I think that Amundsen isn't quite ready for it. Apache Atlas is a bit better at it at the moment. I think that will change over time as Amundsen matures, but Amundsen is definitely focused particularly on data discovery in itself, and it has an opinionated. It's opinionated about that. Apache Atlas is much more for data governance, which is not opinionated about data discovery. Hence, it's actually really difficult to use in that context. But it has a lot better understanding and a more stable API at the moment than Amundsen has.
Great. Well, it looks like we worked through our queue of questions. So, any last thoughts or?
Oh, no. I'd like to invite people to actually, I hope what I did with, showing Amundsen in this case and what kind of difference good quality data and good quality lineage basically can make into this space, and how to actually improve productivity with your data scientists and your data teams, to encourage people to actually, have a look and contribute on the lineage side, because honestly I felt a little bit lonely for some time until I found out that some people are actually using it. But the lineage space has not been very popular with a lot of people within Airflow, and I hope to invite actually more contributors in that space that drive things forward a little bit, because conversations with myself about lineage are just not so much fun. And well, when I explain it to people, actually people do get excited. So, oh, great, let's have it. Yeah, right, okay. But how to do this properly, how to integrate this properly with Airflow where it is, and how to do it where developers understand it and do not feel the burden of doing the metadata thing. That would be definitely appreciated. So if that can be a call to action as a closing remark, then this is a call to action.
Great. Awesome. Well, thanks, Bolke, and thanks everyone for attending this session. The next talk is by Michael Hewitt from Nielsen, and he's going to be talking about Airflow on Kubernetes, containerizing workflows. And with that, I think we're good. Appreciate it, and we'll be back shortly with the next session. You could just stay in this channel, and the next session will start.